Don't be a visitor, be part of the process. Subscribe now. On January 9, 2007, Apple introduced the first iPhone. The first iPhone combined a touchscreen, phone, internet browser, and media player in one device. Today, the iPhone has become one of the world's most recognizable and closely watched technology products.
Apple commands roughly 1/5 of global smartphone shipments, with hundreds of millions of devices moving worldwide.
Over the years, the iPhone has grown from a revolutionary smartphone into a global technology phenomenon.
But an iPhone does not begin on an assembly line. Its journey starts with thousands of specialized materials and components. Before production, incoming materials are inspected for dimensions, composition, cleanliness, and consistency. Metal alloys are prepared as precisely controlled stock for structural components and enclosures. Large pieces of metal are cut into smaller blanks ready for precision machining. Computer-controlled machining removes tiny amounts of metal until the enclosure reaches its engineered shape. Internal cavities are machined to make room for the battery, cameras, speakers, boards, and connectors. After machining, the metal surface is carefully finished to achieve the required texture and appearance. Cleaning removes oils, particles, and machining residue before the housing moves to later production stages. Each enclosure is measured and inspected because tiny dimensional errors can affect final assembly. Meanwhile, specialized glass begins its own journey toward becoming the phone's protective front surface. Precision equipment cuts large glass sheets into individual display-sized panels. The edges are then processed and polished to extremely tight dimensional tolerances. Every panel is thoroughly cleaned. Microscopic contamination can affect display quality.
The display is built from several extremely thin layers that must remain precisely aligned.
Controlled lamination joins the layers while minimizing trapped air and optical imperfections. Touch-sensing circuitry is integrated so the screen can detect precise finger contact. Each display is calibrated for brightness, color, uniformity, and touch response. Automated systems and technicians search for even the smallest visible defects. Flexible cables provide the electrical connection between the display and the phone's main electronics. The completed display module is now ready to meet the phone's internal electronics. At the heart of the phone are semiconductor devices manufactured from highly refined silicon. Complex processes create microscopic electronic circuits. These cover the surface of each wafer. Advanced inspection equipment checks the wafer for defects before individual chips are separated. After processing, individual semiconductor dies are carefully separated from the wafer.
The fragile silicon dies are packaged so they can connect reliably to a circuit board.
Electrical testing verifies that each chip performs within its required specifications. The phone's logic board begins as a compact multi-layer printed circuit board. A stencil printer places microscopic solder paste deposits exactly where components will be attached.
High-speed placement machines position hundreds of tiny components with remarkable accuracy.
Major integrated circuits are aligned with microscopic electrical contacts on the board. The board passes through a controlled reflow process that melts the solder and permanently joins the components. Cameras inspect component placement and solder joints for manufacturing defects. Technicians also inspect selected boards under magnification to verify critical connections. Only boards that pass electrical testing move forward to final phone assembly. The battery begins with carefully processed materials, designed to store electrical energy safely. Active materials are coated onto electrode sheets with tightly controlled thickness. The coated electrodes are dried under carefully controlled conditions before further processing. Electrodes and separator materials are assembled. They are formed into compact lithium-ion cells. New cells undergo controlled charging. Cell is tested for electrical performance before final phase. Protection and monitoring electronics help the battery operate safely inside the finished phone. The tested battery is now ready to become part of the complete device. The camera begins with a tiny image sensor designed to convert light into digital information. Multiple optical elements are assembled into a precisely aligned miniature camera system. Optical calibration ensures the lens and sensor remain correctly aligned. Test systems evaluate focus and sharpness. They also check exposure and color reproduction. Tiny speaker modules are assembled and tested before installation. Microphones are tested for sensitivity and consistent audio response. The haptic engine provides precisely controlled physical feedback when the phone responds to touch. Miniature antenna structures are prepared to handle the phone's wireless communication. Even simple controls require carefully engineered miniature mechanical and electrical components. Every supporting component must pass inspection before entering the final line. Now the separate parts begin coming together to form the finished iPhone. The tested logic board is positioned inside the chassis and aligned with its mounting points. The battery is precisely positioned and secured within the internal structure. Speaker modules are fitted into carefully shaped internal cavities. The haptic engine is secured so its vibrations are transmitted consistently. The camera module is positioned and connected to the phone's main electronics. Front-facing sensors are aligned carefully because their optical position affects their operation. Flexible cables connect the phone's major modules while occupying only millimeters of space. Before closure, every internal connection and component position is checked. The display receives a final cleaning before it is joined to the phone. A delicate electrical connection links the display to the phone's main board. The enclosure is closed, combining hundreds of components. Tiny fasteners are tightened, using controlled torque to secure the internal assembly. After assembly, each phone is powered on and enters a sequence of functional tests. The display is tested for color, brightness, touch response, and uniformity. The camera system is tested again after assembly to confirm focus and image performance. Speakers and microphones are tested. This verifies clear and consistent audio performance. Wireless and cellular communication systems are tested before final approval. Finally, inspectors check the phone's exterior for scratches, contamination, alignment. Only devices that pass the complete inspection process are cleared for packaging. The approved iPhones are carefully packaged and prepared for their journey to customers.
From the factory, finished devices enter distribution networks, serving markets around the world.
Thousands of materials, components, precision operations, and tests have come together to create one finished iPhone.